Okay, so today we're going to show you how to simplify surds and add or subtract with surds. Okay, it's a surd. The surd is the word. Ain't you heard about the surd? So we're going to start off with which of the following are surds. They're all written as a square root of each number. Okay, so the square root of 4 we know is 2. Okay, it gives us a whole number, there's no decimal answer, so this here is not a surd. Okay, the square root of 2. Now if you use your calculator, we can see that the square root of 2 gives us a long decimal answer. Okay, the number keeps dividing. It's what we call irrational number, where the numbers keep going and it's not repeated digits each time. That's recurring. So the square root of 2 gives us 1.412, and it keeps going, keeps dividing. So we say, yes, this is a surd. And we keep it as the square root of 2. It makes it more accurate than writing the full decimal out. Okay, if we have the square root of 36, we know that the square root of 36 gives us 6, so that is not a surd. We get a whole number answer, okay, and no repeating digits. Square root of 7, have a look. So the square root of 7 gives us 2.645, and it keeps going on. Okay, it keeps dividing, it's irrational, so we say the square root of 7 is a surd. Okay, and we leave it in square root form. It makes it more accurate than rounding this to a certain number of decimal places. So we see there what it is. Okay, now we also have to simplify a surd. Okay, so we're saying what square numbers can fit into each of these and how many times does it occur. So as we are going through these, you should, down the side, just write out the square numbers. So you've got 1 squared is 1, 4, 9, 16. We're supposed to memorize the first 15, so up to 225. Okay, so the square root of 50, you can look here. If you pick the number 1, that'll just stay as one lot of root 50. Alright, we have to simplify it. Okay, so which of these fit into 50? Well, 25 does, 36 doesn't, 49 doesn't, and the rest are too big. Alright, so we're going to pick 25. So we say root 50 is root 25 times root 2 makes root 50. We know that the square root of 25 is 5, so that gives us 5 lots of root 2. Okay, that's the final answer there. Root 32. Now here, we could pick 4, that fits in 8 times, or we could pick 16, that fits in twice. We are simplifying, so pick the highest factor, which is 16. So we say root 32 is root 16 times root 2. Root 16 simplifies to 4, so 4 lots of root 2 is your answer. Now 27 on here, these are too big. Alright, looking for the list, 9 is a factor of 27, so we say the square root of 9 times the square root of 3 is root 27. Square root of 9 is 3, so it's 3 lots of root 3. Okay. Now 484. quite a large number. It's in the fours, but is there a bigger factor? That's a square number that goes into 484. And looking down the list, we can pick 121. Okay, 121 times 4 makes 484. Root 4. Square root of 121 is 11, so that's 11 lots of root 4. Right, I've also picked 96 and 48. These often come up and often mistaken. Right, 96. Okay, it is in the 4s, but it's also in the 16s. Okay, now root 16 times root 6 equals 96. Square root of 16 is 4, so it's 4 root 6. 48 is also in the 4s, but it's in the 16s as well, and we pick the highest one. That'll save us simplifying it twice. So root 48, I'm going to say, is root 16 times root 3. Root 16 is 4, so it's 4 lots of root 3. Right, that's the simplifying finished. Okay, so write out your square numbers and which ones of them fit into the number. Okay, so moving on down, adding and subtracting with surds. Now this is just like algebra. Okay, you can only add the same letters. So you got 3b plus 4b equals 7b. Now it's the same with surds. You can only add and subtract the same surd. Okay? If they're not the same, then you must make them the same. So one lot of root 2, add another lot of root 2, is not root 4, it is 2 lots of root 2. Okay? You've got one lot of root 5, add 2 more lots of root 5, gives you 3 lots of root 5. Okay? The next one, 4 root 7, take away 5 root 7. Well, 4 take 5 is minus 1, so it's minus 1 lot of root 7. Right, the last 3, okay, these are different surds, okay, so we must make them the same, okay. Now this is in root 2, so this must also make root 2. So we're going to simplify this bit first. Now 8, we can see from our list, 4 can fit into 8 twice. So that's root 4 times root 2. Cancel it down, gives you 2 lots of root 2. And these here, you're going to have 5 root 2, add 2 root 2, gives you 7 lots of root 2. That's all we do. Okay? And this one here and here kind of gives it away. Alright, so we must make this as root 3. Now which square number can fit into 75 3 times? It's 25. So we say root 25 times root 3. Okay? That cancels to 5 root 3. And we're going to take away 1 lot of root 3. Take root 3, that's not 5, because 5 root 3, take 1 more lot of root 3, gives you an answer of 4 lots of root 3. Now, quite often in the exam, you are given this as your question. It does look like a mouthful, okay? So it's expressed in the form of a root 2, where a is an integer. Now a, integer, just means whole number. Okay, and it tells you it must be in root 2. That one is in root 2, this one is not. Okay, so what square number can fit into this twice to make the root 2? It's 49. So we'll simplify this bit. So you've got root 49 times root 2 equals root 98. Cancel it. 7 lots of root 2 when you simplify. Here you've got this 1 root 2. So you've got 1 root 2, add 7 lots of root 2, will give you an answer of 8 lots of root 2, where 8 is your integer. Get on!